Hello and welcome to this training video. Today we will learn about the DXP Open Edition, Planet 9, and using server scripts with APIs. Utilizing APIs built in the API Designer within server scripts within Planet 9 has never been easier thanks to updates to the script editor and its code snippet features. Let's open up the script editor. The runtime for scripts is a node environment running inside a separate process or as a global process always running in memory. Next, let's create a project. Once you have created a project, you will be able to view all the resources within your system that you can utilize within server scripts. These resources consist of APIs, tables, global scripts, and NPM modules, both internal and custom. Create a script within your project by right-clicking on Scripts and pressing New Script. To link a script and API, simply locate the API and operation within the resource panel. Drag and drop the operation onto the script. Here you can give the operation a custom name if you'd like. Once it has loaded in, the easiest way to utilize the API is to use the automatically generated code snippet. This can be accessed by right-clicking within the code editor and selecting Code Snippets. Locate API on the left of the dialog, expand it, and you will see the operation you have imported. Clicking on it will reveal automatically generated code for that specific operation. In this example, since I have defined default values, you can see they have carried across from the API Designer. This means this code snippet can be run straight away. You can see the API is triggered on line 12 using an await, followed by APIs dot the name of the operation. This will store the result of the response within the result constant. This result can then be utilized within the script. We can see the data within results by right-clicking anywhere on the script and running the script. This will open a dialog which will display the console for the process, and since we have a console.log of our result, we can see the data from the API printed here. Let's utilize some other useful code snippets to expand this example. Imagine you had an application that allowed a user to type any location to request the weather data for that location. The app would take the input from the user and call this server script via an API. The script would then take the given location, call the weather API from within the script, and then pass the result out of the script back to the application to display to the user. We can implement this functionality easily, again, by utilizing code snippets. We can right-click, open the code snippet dialog, and under the data subheading, we have a really useful snippet for handling data coming in to server scripts. The request snippet details how to utilize the HTTP request object when the script is used as an API endpoint. You can utilize the request body, request query data, and the user details of who made the request. We can grab the rec.body line to put the information into a constant called data. We can then add one line of code, a log.info, and in brackets data, which is similar to a console log, but will output to the system logs within the platform. We will see where these are in a minute. First, I will speed through creating an API that talks to our weather server script within the API Designer, before moving into the App Designer to create a very simple application with an input field and a button that will allow us to interface with the server script. The API is of type external and uses one post operation called /getWeather, which passes an object into the header. This object will be a key of location and a value of whatever is in the input field of our application. To make the app, I open up the app designer, drag and drop the components, which is mainly an input field and a button, onto the page. The press event of the button will trigger the API call, which I'll also drag and drop into the resources of the app. I can then write the object to be sent in the header of the API, and we can test the app with the developer tools open to see the status of the API call and the header with the object in. Now we can visit the system logs tool and open the drop down for server script. This is where all the log.info, log.warning and log.error messages will print to from any server scripts that include them. Since we put a log.info of the rec.body, we can see a log which contains an object, and if we open it up we can see the location is Paris. Now within the script it is as simple as taking the data.location, swapping our hard-coded location of London to the incoming data.location, and then swap the console.log to a log.info to see the result of the API call with our dynamic request variable sent from our application. So here I send the request again for Paris, and in the server logs, after an update, we can see the new log of the API response with the location set as Paris. Next, we can look at the two different methods for interacting with a table from a server script. I have an example table within the platform called Amazing Table. We can refresh master data from the drop-down menu on our project to update our resource panel if it isn't showing because it's a new component. We can see it under the table subheading, and we can drag and drop it onto our script. We can right-click on the table to view and edit it in the same way the table browser tool allows us to. Now, let's jump back into the API designer and quickly import the same table as a table definition API before returning to the script and refreshing the master data again. Now we can see the API and its CRUD methods for the table. Let's drag and drop the post method into our script. We now have two different ways of interacting with the same table from one script. We can open the code snippets to see how Neptune generates the /post API code for adding data to the table by defining the object and sending an API request within a try catch. Alternatively, under entities, you can find the relevant action. You can see the code snippet for our amazing table, allowing us to create or insert records with the same end result as utilizing the API call to do so. Finally, we will have a look at how global scripts work. Creating a global script is easy. Simply right-click on any script within your project and select Mark as Global. This will push the script into the global subheading for the project. You can always right-click on the global script and remove the global flag to revert this action. After refreshing the master data for the project, you will see the script is now available as a global resource. This means it can be dragged and dropped into another script, and anything within the global script can be referenced from the parent script that contains it. This is easier to understand with an example. Here we have a global script that contains an async call to a database. Since one of the benefits of a global script is that it is always running, unlike normal scripts which are only run when triggered, this will quickly return the result of the function. Now, this global script is used within other scripts within this project. Here under the other scripts, you can see the resources that contain the global script. This allows them to use the globals dot and then the global script's name, so MSSQL, followed by a dot and then the name of the function within the global script, which is getAuth. This then calls the function within the global script. This enables code reusability, not only within one project, but also even in other projects. Any scripts marked as global will be visible and can be utilized. Here you can see I make a new project and utilize the global script we created in the previous project. Naturally, these global scripts can also have API resources, the same as a standard script. However, the API must be added to the script before it is set to global.